All right, class, so this is an explanation video for the first part of this extra ice table practice worksheet. So in this first question, we're given a chemical reaction, and the goal of this question is to calculate the value of Kc. So I'm going to put a box around that, put a question mark there. And then we're given some initial conditions. So I've got 6.75 grams of my reactant, my starting material, and then I'm putting that in a 2-liter flask. The importance of the 2-liter flask is that I want to calculate the molarity, so I want the concentration. So whenever we're calculating a Kc, right, I want to make sure that I'm using concentration. So let's just go ahead and write that out. Kc is equal to the concentration of SO2 over the times the concentration of Cl2, and that's all going to be over the concentration of my starting material, SO2, Cl2. And again, these are concentrations, so I want to make sure that I have that in mind when I'm doing this calculation. So the first thing that I would do, I know that I'm going to need to use an ice table to solve for this to find my equilibrium concentrations, since I have equilibrium arrows here. And I'm going to just convert the 6.75 grams into moles, and then use the 2 liters to convert that into molarity. So I'll do it over here to the side. 6.75 grams of SO2 Cl2 times 1 mole over 134.96 grams, so just calculating the molar mass there. So that's going to be equal to 0.0500, very convenient number here, moles of SO2 Cl2. Then I'm going to convert that into molarity just by dividing that by 2, and then you get a molarity, so let's just do divide by 2.00 liters. And that's going to give me a molarity of 0.025 molar SO2Cl2. So this is my initial amount, my initial concentration of SO2Cl2. So in my ice table, ICE, that's what I'm going to put in here, 0.025 molar. And then I'm going to have zeros for my SO2 and Cl2. So this problem does not tell me any initial conditions for SO2 or Cl2. So I'm going to assume that they are 0. And then we're going to go to equilibrium. So obviously, since these are zeros, in my change line, I'm going to have a minus x here, plus x here, and plus x here. And then at equilibrium, my expressions, so sort of, mathematically, I'm going to have 0.025 minus x, whatever this x value is, of this SO2Cl2 remaining. I'm going to have x and x molarity of SO2 and Cl2, so there'll be a 1-to-1 ratio there. So then the last part here is I need to figure out what this x value is, right? We're trying to ultimately solve for Kc, but we need to figure out what those equilibrium concentrations are before we can solve for Kc. So we're told that at equilibrium, once at equilibrium, there is this amount, 0.0345 moles of SO2 present. Again, obviously I'm going to want to convert that to molarity. I want to make sure that we're consistent there. So if I take 0.0345 moles of SO2 and I divide that by 2.00 liters, that's going to give me my molarity of SO2, and that's going to equal 0.01725 molar SO2, and that's my x value. So make sure I got that number right. Yeah, that looks good. So this is my x value, right? This is the concentration of SO2 at equilibrium, and that is what x represents. That x right there, it represents the concentration of SO2 at equilibrium. So I might just write here, x is equal to 0.01725 molar. Now, I can use that x value to solve for my equilibrium concentrations of everything else. It's going to be the same for Cl2, right? It's x and x. But then for SO2Cl2, I can just do that calculation there because this expression here tells me what the equilibrium concentration should be. Once I have those values, I can just plug them into Kc and solve for the value of Kc. So that's going to look like 0.01725, 0.01725, all over this, which is then going to end up being 0.00775. And I do this simple calculation and I get a Kc value of 0.0384. So that is my final answer there. That's the value of Kc. The units for this would just be molarity. I've got molarity times molarity over molarity, so sort of one of those molarities will cancel, just leaving me units of molarity. So you can put that in there if you want. Not usually super necessary, but it's good practice. All right, hope that helps.